This is question 33. We're looking at independent probability of two separate events. Well, not separate, but they don't affect one another. In other words, I've got red and black chips in jar 1. If I pull a red chip, it does not affect the probability of pulling a red chip in jar 2, if that makes sense. So what I'm going to look at here is in jar 1, okay, and I'm only looking in jar 1 right here, there are a grand total of 10 chips, 4 red and 6 are black. Now the probability then that you would pull a red out of jar 10 is 0.4, and the probability that you would pull a black is 0.6. Now, normally I use the decimals in probability, but I'm looking over here, and I am noticing that they use the fractions. So what I'm going to do is just make these into fractions. Remember that 6 is, or 0.6 is 6/10. 6/10 is the same as 3/5. Okay, and 0.4 is the same as 2/5. Okay, then I'm going to do the same thing for this other jar, for jar 2 here. There's still a grand total of 10, okay, but in jar 2, it's actually 50-50 chance. So this is 5 out of 10 for red in jar 2, and 5 out of 10 is the same as 1/2. And then for black, it's also 5 out of 10. So that's 1/2 as well. So each of these has their own probability. So let's start with just jar 1, okay? And look at what are the two probabilities. The first thing that you might draw is a red. The second one is black, okay? And then what would happen with jar 2 is you might get after you draw a red, okay, there's still two distinct possibilities of what could happen here. You could get red again, or you could get a black. And the same thing is true if you were to have pulled black first. In jar 2, you still have a chance of a red, then a black. So what you're going to do is apply to each of these the probabilities. So the probability of red is 2/5 in the first jar, and it's 1/2 in the second jar. Okay, and the probability of black is 1/2 in the second jar. Okay, in that first jar, the probability of black is 3/5. And again, the probability of red was 1/2 and 1/2. Okay, so whenever you've got like a branching, check and make sure 2/5 plus 3/5 here, that adds up to 5/5, which is 1 or 100%. Now then, you only add up things that are on the same branches. So 1/2, 1/2 for jar 2, and that's 100 or 1. Also. Now then you just multiply probabilities. Okay, the probability here is 2/5 times 1/2. Okay, which makes 1/5. Okay, the probability of red times black here is 2/5 times 1/2, which is also 1/5. The probability of black times red, okay, is 3/5 times 1/2, which is equal to 3/10. And the probability of a black and a black is 3/5 times 1/2 as well. Okay. So looking at this, and keep in mind, this should add up to 1 as well. So this is 1/5, but I'm going to say 2/10 plus another 2/10, which is 4/10. 5, 6, 7, 8, 9, 10/10 is what those add up to. So I know that I did the math right. Now then, the question was the same color. Okay, that happens on this branch, and that also happens on this branch. Okay, so 1/5, which is the same as 2/10, and 3/10, if you add those together, okay, you would end up with 5/10, and 5/10 is the same as 1/2, and that is C. Now I want to show you very quickly, there is a way to look at this. I really like sample space, or to use sample space usually in probability, because it's just real, like I know I did the right operation. So this is how you could do that. In jar 1, remember there were, and let me make sure I'm right about this, yeah, 4 reds. You could actually kind of do it like this. There are 4 reds, and then there were 6 blacks. 3, 4, 5, 6. Okay, and then I'm going to do jar 2 right here. Okay, so jar 2, I'm just going to write it right there. It was half and half, so there was 1, 2, 3, 4, 5 reds, and there were 1, 2, 3, 4, 5 blacks. Okay, now if you look at this and just make a check mark if you have 2 of the same color, so right here and here, red and red, that's a check. Red and red, another check. Another check, another check. This, if you'll notice right here, black and black, or red and black, these are not the same. None of those are going to be the same. Okay, I'm not going to put the X's there actually because it just confuses me. These are the same, then they start not being the same back there. And these are the same, and these are the same, and these are the same. Okay, and then looking here, none of these are the same. Absolutely none of these, because it's going to be red times black. Okay, but these are going to be the same. Let me put that X here. We've already figured this out. Because these are going to be the chances of black times black. 1, 2, 3. I'm going to do this with area anyway, so I'm not going to count check marks. All of those are the same. So the question is, number 1, how many total do you see in this picture? And since it's 10 times 10, just kind of calculating area, that's 100 possible things that could happen. Okay. And the reason that it's 100 is that it's going to calculate it as if each bead had its own name, or each chip, sorry, had its own name. But that's okay, because it'll divide out to the simpler fraction. Now then, this is an area right here where they're the same. That is 4 times 5. That's 20 checks in there. And this is an area that is 6 times 5, which is 30. There are 30 checks. That means that they have the same color in that area. So there are exactly 50 ways to have the same color when you're pulling from the 2 jars out of 100 things that could happen, and 50 out of 100 is 1/2. So that's a way to do it with a sample space.